Hello and welcome to our fourth lecture. So today we're looking at factorization by grouping. In the previous class, we just checked factorization and did some simple examples. And in this particular class, we're going to take the class a notch higher by handling algebraic expressions that necessarily do not have common factor in each term. I want you to look at the example we have below. So we're having ax plus a plus bx plus b. And I want you to note that the whole expression doesn't have any common factor. A is in the first term, in the second term, not in the third, not in the fourth. X is in the first term, not in the second, in the third term, and not in the fourth. And you will notice that with all the terms that we really can't particularly point out to any specific common factor or common divisor in the terms of this particular expression. And so in that particular case, we usually do factorization by grouping the terms in pairs. We do factorization by grouping the terms in pairs. So the first thing you want to note is that all the terms are treated as pairs. So we're going to treat the first two terms as a pair. That is ax and a. We're going to treat that as a pair on its own, and we're also going to treat bx plus b as a pair on its own. And the trick of it is to find a common factor in each of these pairs and factorize the pairs independently, then observe what will happen after we've done that. So basically, let us go ahead and factorize the first pair. So ax plus a, you notice that the common factor there is a. So we're going to factor a out, and when we factor a out, we're going to have a into x plus 1. All right, we're going to have a into x plus 1. By now, I assume that you are familiar with factorization, and that is why I haven't gone into the nitty-gritties of how we are having x plus 1 into the bracket there. So basically, it is ax divided by a to give us x, and a divided by a, okay, a divided by a to give us the 1 that you're seeing within the bracket. Now, we're going to go to the second pair of our algebraic expression, and again factorize what? Factorize the common factor, which in this case will be b. B is in bx, b is also in b. So we factor that b out, and note we're going to have bx divided by b giving us x, and b divided by b giving us 1. Good. So we've already factorized all the two pairs of the algebraic expression. And now, before I continue to the next step, I want you to note that the terms in the brackets are alike. They are identical. Note, x plus 1 is identical to x plus 1 on the other side of our factorized algebraic expression. And usually that is what you're looking for. Whenever you have those identical terms in the brackets, then you can then go ahead and factorize by grouping. And so what this will mean for us is that we are going to pick whatever term we have in the brackets, that is x plus 1, as a term, and we're going to multiply it by whatever we have as our common divisors outside the brackets. So that is a plus b. And this here will be the factorization of this algebraic expression, that is ax plus a plus bx plus 1. Thank you. Let me handle the second example for a better understanding of the concept. Okay, on to the second example. So we are given instructions to factorize 3ab, 3ab plus 2b plus 3ca plus 2c. And I want you to note that we don't have any common factor across the algebraic term, okay? We don't have any common factor across the algebraic term. When you speak of 3, 3 can go in here, can't divide this, can divide this, can't divide this, okay? When you speak of a can divide this, a can't, is not a common factor here, a is a common factor here, a is not a common factor here. When you speak of b, b is a common factor here, it's a common factor here, not here, not here. And so for us to then factorize this particular expression, we are going to have to treat it as a pair. Okay, and I also want you to note that most of the expressions that we're dealing with here are actually having 4 terms. Okay, we are having 1, 2, 3, 4. Those are 4 terms in this particular expression. So we're going to treat the terms, we're going to pair the terms up into pairs of 2, and then factorize each pair on its own to identify if there is any identical terms in the brackets. Okay, so we're going to start with this first pair. All right, that's going to be 3ab plus 2b. All right, we're going to start with that. So looking at that, we are going to know, you'll note that what is the common factor there? B. Okay, you're going to know that B is the common factor there. And so we'll just pull our B out as our common factor. Then we're going to take 3ab divided by B, and that will give us 3a, plus 2b divided by B will give us 2. 2b divided by B will give us 2. Now we're going to go to our other pair, and that is 3ca plus 2c. And we will do the same thing. We are going to factorize it using the common factor method. All right. So looking at the second pair, we note that c is the common factor there. All right. And so we're going to pull that c out into 3ca divided by c will give us 3a, plus 2c divided by c will give us 2. Good. Now, I want you to note that the terms we have within the brackets are actually identical, okay? 3a plus 2 is identical to 3a plus 2. And therefore, that already satisfies our requirement for us to then go ahead and factorize this particular expression by grouping. So we are going to maintain the identical terms within the bracket. And so that's going to be 3a plus 2 into whatever common factors we are having outside the expression, and that's going to be b plus c. Now, if you were to expand this particular simplified version of our expression, you'd go back to this particular expanded version. And so that is going to be our answer for this particular, that's going to be our solution for this particular example. Let us handle the last solution in this subtopic. Finally, as we do our last example, note we are going to factorize x squared plus xy plus 2x plus 2y. I want you to first note that we do not have any common factor within the expression. X is common here, common in this term, common in this term, but not common in the last term, okay? All right, Y is not common here, it is common here, not common here, yeah? And you can see that across the board, all right? So basically what we're going to do, we are going to then try and pair the terms that we have in the expression as, you know, into 2, all right? So we're going to take the first pair here and factorize it on its own, and then, you know, take the second pair, then factorize it basically on its own as well, to see if we end up having any identical terms within the brackets. So starting with the first pair, we're having x squared plus xy. All right, x squared plus xy. I want you to note that x is common in the two terms, x squared and xy. All right, so x is common. And whenever we have that particular scenario, I told you that we take x with the lowest power. So in this particular case, x has the power of 2, which is greater than this, than this one here, which has a power of 1. So we're going to treat our highest common divisor there, our GCD, in this particular scenario as x. All right, by picking the x with the lowest power. So we're going to have x squared divided by x, and that will give us x. That is 2 minus 1, the power of x squared, 2 minus x raised to 1, that is 2 minus 1, giving us x raised to 0, and, you know, giving us x raised to 1, which is basically x. All right, and then in this particular case, you're going to have x or xy divided by x, xy divided by x, and basically that is x will simplify the other x out, and that will give us y. X will cancel the other x out, and that will leave us with x plus y in the bracket. So that's it with the first pair. So we go on to the second pair, identify the common factor, and factorize again. So in the second pair, note we are going to have 2x. All right, we're going to have 2x plus 2y. And in this particular expression, note that 2 is the common factor. All right, 2 can divide this term, 2 can divide this term. So we're going to factorize 2 out. And so whatever we left in the, whatever will be in the bracket will be as a result of dividing 2x by 2. So 2x divided by 2 will leave us with x plus 2y divided by 2. 2y divided by 2 will give us y. So note that whatever terms we have within the bracket are identical. Okay, so we are having x plus y in this particular case and x plus y in the other case. So that qualifies this expression to be factorized by grouping. And so we are going to have our first bracket as x plus y from the identical terms, and then the other pair of this factorization will come from the common divisors, and that is going to be x plus 2. That is x that is out here, and 2 that is outside, outside this other pair of identical term. And so that will be it for today's class. See you in the next one. Thank you.